Hello and welcome to the lecture. So, in the previous lecture, we were studying about back bonding, and we have dealt with many examples, and I hope that now you may have a better concept about back bonding. Now, in this lecture, we will study about what is the effect of back bonding on hybridization, shape of the molecule, and bond angle of the molecule. Now, the first statement that you should write is that back bonding, it does not have any effect on hybridization. So we can say that no effect of back bonding on hybridization. So suppose we have this molecule BF3 molecule. Now as we know that here what will happen, back bonding will occur because here we have empty orbital on bromine and we also have lone pairs on fluorine. So there will happen back bonding. So initially it will have sp2 hybridization. Now when back bonding happens, hybridization will remain same. Hybridization will remain same. So it means that there is no effect of back bonding on the hybridization. Now we will see what will be the effect of, we will see another thing, that is what will be the effect of back bonding on the shape of the molecule, on shape of the molecule. So we will look, let us take an example so that we can understand what will be the effect of back bonding on the shape of the molecules. And this is one of the very important concept which one should learn, so that we can solve all the questions which can be asked in the exams related to this concept. Now suppose we have this molecule, we have here nitrogen and we have SiH3. So this is the molecule. Now in general, this molecule, this should have the shape of the molecule. For this molecule, it should have been pyramidal. Shape of this molecule, it should have been pyramidal. So since this nitrogen, it is having hybridization of sp3. So the molecule, it should have this type of shape. So this is nitrogen and this is silicon with 3 hydrogens. This is silicon with 3 hydrogens and this is silicon with 3 hydrogens. But since here this nitrogen, it contains lone pair of electrons, and also in silicon we have empty p orbital. We have here empty orbital. So here also in this silicon we have empty orbital, and also in this silicon we have an empty orbital. Now because both lone pair as well as empty orbital is present, so both conditions that are necessary requirement for the back bonding, both conditions are met by this molecule. So we can say that here back bonding will occur like this, and like this. Now as we know that geometry or shape of the molecule, it is decided by the lone pair. Now this lone pair, since it is distributed as a result of back bonding, so there will be here, so this lone pair, it will have minimizing inter-electronic repulsion, that is, it will have so there will be minimization of electronic repulsion between the lone pair and the bond pair. So in other words, we can say that because of less repulsions, the shape of the molecule it changes. The shape of the molecule it changes. So it changes into planar molecule. So this molecule it will have the shape of this molecule. It is like this. It is silicon here, and it is silicon here, and here it is silicon here. So because of back bonding, initially the shape of this molecule it was pyramidal. It was pyramidal. Now as a result of back bonding, the shape of the molecule it changes into planar molecule. It changes into planar molecule. Similarly here, bond angle it also changes. Bond angle it also changes. Initially the bond angle it was approximately equal to 105. Now this bond angle, that is theta, it changes into bond angle of 120. So this is the concept, that because of back bonding, the repulsion that was found between lone pair and bond pair it gets minimized, as a result of which bonds they relax, and the shape of the molecule it changes from pyramidal to planar. So this is the concept that we should understand. Similarly, we have another molecule. The molecule is like this. We have another molecule like nitrogen, and if we have GE, germanium hydride 3. So here also back bonding happens. Here also back bonding happens. So let us explain how back bonding happens and what will be the effect of shape on this molecule. Now, as expected, because of this lone pair, because of presence of lone pair on the nitrogen, the molecular shape of this it should have been trigonal. It should have been pyramidal, like this. So this molecule it should have been pyramidal. Now because of back bonding, so here back bonding will occur. Here also back bonding will take place. Now because of back bonding, the shape of this molecule